Hello students, in today's e-lecture we will discuss more questions based on adjoint and inverse of a matrix. Let's take first question. In this question we have to find adjoint of a matrix. Then we have to show that product of A and adjoint A equals to product of adjoint A and A equals to determinant of A multiplied by identity matrix. Also to find inverse of matrix. First of all, find determinant of matrix A of order 3. To find determinant of matrix A, expand it along R1, simplify it, we get determinant of A equals to 27. In next step, find cofactors of each element of A. To find cofactor of any element, first delete that row and column in which element exists. Then find the determinant of remaining elements. After that, multiply this determinant by position sign of the elements. We get cofactor of that element. Then write the cofactor matrix of A. For that, replace each element of matrix A by its cofactor. We get cofactor matrix of A in which elements of R1 are -3, -6 and -6. Elements of R2 are 6, 3 and -6. Elements of R3 are 6, -6 and 3. In next step, by taking transpose of cofactor matrix of A, we get adjoint of matrix A. Now, following the rule of matrix multiplication, take product of matrix A and adjoint of A as shown here. After simplification, we get a scalar matrix in which each diagonal element is equal to 27. This scalar matrix can be written as 27 multiplied by identity matrix. As 27 is the value of determinant of A, so product of A and adjoint A equals to determinant of A multiplied by identity matrix. Similarly, we can verify that product of adjoint A and matrix A equals to determinant A multiplied by identity matrix. Let's find A inverse. Now, A inverse equals to 1 upon determinant of A multiplied by adjoint A. In next step, substitute the values, simplify it. We get inverse of matrix A equals to a square matrix of order 3 in which elements of R1 are -1 by 9, 2 by 9 and 2 by 9. Elements of R2 are -2 by 9, 1 by 9 and -2 by 9. Elements of R3 are -2 by 9, -2 by 9 and 1 by 9. Moving to the next question. In this question, a square matrix A of order 2 is given. We have to show that A square minus 6A plus 17I equals to null matrix O and hence find A inverse. Hence find A inverse, it means using this matrix equation we have to find inverse of matrix A. First, find A square. To find A square, multiply matrix A by A as shown. After simplification, we get A square equals to a square matrix with elements -5, -18, 18 and 7. Now, in the expression A square minus 6A plus 17I, in place of A square, write the matrix obtained already. In place of A, write the given matrix. In place of I, write the identity matrix of order 2, because order of square matrix A is also 2. In next step, multiply the matrix A by -6 and matrix I by 17. After that, add the corresponding elements of matrices as shown. We get A square minus 6A plus 17I equals to null matrix. Now, find determinant of A, which is equal to 17. As A is non-singular matrix, so inverse of matrix A exist. But in this question, we have to find A inverse using given matrix equation. Students, whenever we have to find A inverse using matrix equation, first write the term of identity matrix on one side and remaining on the other side. So, we write it as 6A minus A square equals to 17I. In next step, pre-multiply A inverse on both sides. Write it as 6 multiplied by A inverse multiplied by A minus A inverse multiplied by A equals to A inverse multiplied by 17I. Here A square can be written as A multiplied by A. As A inverse multiplied by A equals to identity matrix, so in next step we write it as 6I minus I multiplied by A equals to 17 multiplied by A inverse multiplied by I. As we know that any square matrix multiplied with identity matrix of same order is equals to matrix itself, so we get 6I minus A equals to 17 multiply A inverse. Then A inverse equals to 1 by 17 multiplied by 6I minus A. In place of I and A, write the identity matrix and given matrix. Simplified as shown, we get inverse of matrix A equals to 1 by 17 multiply with a square matrix of order 2 in which elements of R1 are 4 and 3 and elements of R2 are minus 3 and 2. Let's take another question. In this question, A and B are two square matrices of order 2. We have to verify that inverse of matrix AB equals to product of B inverse and A inverse. First, following the rule of matrix multiplication, find product of matrices A and B as shown. In next step, find determinant of AB which is equal to minus 11. Since determinant of AB is not equal to 0, so AB inverse exists. Students, as we have already discussed in previous e-lecture that adjoint of a square matrix of order 2 can be obtained directly by interchanging the diagonal elements and changing the sign of non-diagonal elements. So here we get adjoint of AB equals to a square matrix with elements minus 14, minus 5 and minus 1. Multiply adjoint of AB with 1 upon determinant of AB. Simplify it, we get inverse of matrix AB equals to 1 upon 11 multiply with a square matrix of order 2 with elements of R1 14 and 5 and elements of R2 5 and 1. In next step, find determinant of A equals to minus 11 and determinant of B equals to 1. As both determinants are non-zero, so A and B are non-singular matrices. Therefore, A inverse and B inverse both exist. In next step, find A inverse and B inverse as shown. Now, to find product of B inverse and A inverse, write the matrices already obtained. Here, minus 1 by 11 is scalar quantity, so write minus 1 by 11 as it is and take product of these two square matrices as shown here. After simplification, we get product of B inverse and A inverse equals to 1 by 11 multiply with the square matrix of order 2 in which elements of R1 are 14 and 5, elements of R2 are 5 and 1. Hence, inverse of matrix AB equals to product of B inverse and A inverse. Students, we can remember this result as reversal law of inverse of matrices. It can be used directly also if required. Let's take one more question. In this question, A is a square matrix of order 2 and inverse of matrix B is given to us. We have to find inverse of matrix AB. Here, we can use the result that inverse of matrix AB equals to product of B inverse and A inverse. B inverse is already given to us. We have to find inverse of matrix A. For that, first find determinant of A, that is equals to 5. In next step, find cofactors of all the elements of A. Then write the adjoint of matrix A. In case of square matrix of order 2, you can write the adjoint of A directly also by interchanging diagonal elements and changing the sign of non-diagonal elements. In next step, write inverse of matrix A equals to 1 upon determinant of A multiplied by adjoint of A. As we know, AB inverse equals to B inverse A inverse. Write the matrices B inverse and A inverse as shown. Multiply scalars 1 by 3 and 1 by 5, that is equals to 1 by 15. Also multiply these two matrices by following the rule of matrix multiplication. We get inverse of matrix AB equals to 1 by 15 multiply with the square matrix of order 2 in which elements of R1 are minus 1 and 2 and elements of R2 are minus 5 and 5. Now moving towards home assignment. Do remaining questions of exercise 4.5. Thank you.